Hey everyone, so in this video we're going to go over Boyle's law. So what is Boyle's law? Boyle's law describes the relationship between pressure and volume of a gas at a constant temperature. As pressure increases, the volume decreases, and vice versa. As pressure decreases, the volume will increase. So with that in mind, let's go over the first problem here. A gas occupies 4 liters at 2 atmospheres of pressure. What will the volume be if the pressure increases to 4 atmospheres? So using our Boyle's law equation, P1 times V1 is equal to P2 times V2. So that just means the initial pressure times the initial volume is equal to the final pressure times the final volume. So to isolate here, we're going to have to isolate for V2. So P1 and V1 over P2 is equal to V2. And now we can plug in what we know. So 2 atmospheres times 4 liters over 4 atmospheres is going to be equal to V2. And our final volume is equal, is equal to 2.0 liters. Let's try the next problem. A gas at 1.5 atmospheres occupies 3.5 liters. What is the pressure if the volume is decreased to 2 liters? So here, once again, we can start with our equation. P1 times V1 is equal to P2 times V2. So we have 1.5 atmospheres. It occupies 3.5 liters. And we're looking for the final pressure. So we're going to isolate for P2, and we're going to have to divide by the final volume, which is 2.0 liters. And just quickly thinking about this, if we decrease the volume, since we're going from 3.5 liters to 2.5 liters, the pressure is going to have to increase since it's an inverse relationship. And when we plug this into the calculator, we're left with a final pressure of 2.625 atm, which in fact increased from the original 1.5 atm. Let's try one last problem. A gas ampoule has a volume of 600 milliliters at 0.95 atmospheres. What is the volume at 1.2 atmospheres? So here, quickly, if the pressure is increasing, the volume must decrease. But let's plug it in. Let's plug into our formula. P1 V1 is equal to P2 V2. We have 0.95 times 600 milliliters is equal to 1.2 and then V2. So actually what we can do, since we're isolating for V2, we can just leave V2 over here. And for P2 here, we'll put 1.2 atmospheres. And so we said the volume has to decrease. And when we plug this into the calculator, we're left with 475 milliliters equals our final volume, which in fact decreased from the original 600 milliliters we had. So Boyle's law once again was followed here. So a few tips to remember: always convert milliliters to liters if needed. So just know that if you have milliliters in your equation, your final answer is going to be milliliters. So keep your units consistent, and you can use cross multiplication if you're unsure. And remember that Boyle's law only applies at a constant temperature. I hope this video helped. Thank you.